Hi, I'm Ken Moriarty. We're going to talk about fuel, specifically unleaded gasoline. We're going to explain what fuel is, how fuel is tested, how fuel affects vehicle performance, and what you Buick service technicians can do about fuel-related drivability problems. We're at the GM Proving Grounds to look at part of the fuel story. The emissions lab here at the Proving Grounds tests a wide variety of automotive fuels to assure that all GM vehicles perform up to specs and meet every EPA emission standard. Let's begin by looking at fuel standards and composition. The emissions lab tests consumer-marketed fuels to set the standards for new vehicle computer calibrations. Joining me here in the emissions lab is Les Milvick, a GM fuels engineer.
Hi, Ken.
Les, is choosing the right fuel, a good gasoline, really a matter of luck?
You might say that, Ken. In the real world, motorists buy generally what's available. Our advantage here in the lab is that we actually distinguish between good fuel and bad fuel.
The common automotive fuel, gasoline, is composed of liquid hydrocarbons.
That's correct.
Now, a hydrocarbon molecule contains hydrogen and carbon. There are hundreds of different hydrocarbon molecules that make up gasoline. And because there are thousands of ways to mix or blend gasoline, each oil company makes their gasoline just a little bit different.
But there are only three primary hydrocarbon types in gasoline: aromatics, olefins, and paraffins. Aromatics have a circular carbon arrangement. Olefins have a carbon double bond. And paraffins have a carbon single bond.
Now, this equipment divides a gasoline sample into the separate aromatics, olefins, and paraffins.
Yes, and this instrument does that separation. And that information is transferred to this computer, and on this screen I can see each individual hydrocarbon. Then I can take and group that information into aromatics, olefins, and paraffins. Olefins and aromatics contribute to the octane quality of the fuel, and the paraffins make up the balance of the fuel. Aromatics, olefins, and paraffins exist in simple and complex form. In other words, small and large form. And the smaller paraffins are very volatile, meaning that they evaporate very quickly. That helps start the engine in the morning. The large paraffins are less volatile, but contain more energy. In addition to gasoline's three major components, oil companies blend anti-knock agents, anti-oxidation agents, metal deactivators, corrosion inhibitors, dyes, anti-acing agents, detergents, and deposit control agents to improve performance. For example, most fuels contain detergents and deposit control additives that help prevent and remove deposits which are formed in the combustion areas of the engine. To help ensure performance, the American Society for Testing and Materials, commonly known as ASTM, sets standards for automotive gasoline. ASTM D4814 is the current specification for gasoline. Octane, volatility, copper corrosion, gum content, sulfur content, lead content, and fuel stability are defined.
Of the regulated factors, octane and volatility directly affect drivability. During normal combustion, fuel mixes with air and evaporates before entering the cylinder. During combustion, the ignition system sparks the compressed air-fuel mixture. In a rapid, even progression from the spark plug across the top of the cylinder, the flame front advances and consumes the air-fuel charge. The heat generated from the burning fuel expands the cylinder contents dramatically. The force created from this expansion drives the piston downward. Engine knock occurs after the spark plug fires, but before the normal flame front consumes the air-fuel mixture. Now in this case, an uncontrolled explosion of the compressed air-fuel mixture occurs from a red-hot engine deposit in the cylinder. If engine knock is not corrected, then serious piston damage may occur. Octane is a measurement of a fuel's anti-knock capability. The higher the octane number, the higher the anti-knock capability. Octane is rated using the average of two methods of testing, the research method and the motor method. The research method rates a fuel's ability to resist engine knock during low to medium speeds and to prevent engine dieseling or run-on. The motor method rates a fuel's ability to resist engine knock at part throttle and high speed, such as passing or hill climbing. The pump octane number is the average of the research and motor numbers. Previously, lead-based additives served as octane boosters. Now, since lead is no longer a fuel component, oil refineries have been forced to find new octane boosters.
Oxygenated fuels is one answer. Oxygenated fuels raise octane and lower tailpipe emissions. Gasolines with either ethanol or methanol added to the blend are two examples of oxygenated fuels. Ethanol and methanol are alcohol-based anti-knock additives. Ethanol has the ability to absorb water, preventing fuel line freeze-up. But ethanol only absorbs water to a point. Beyond that point, however, any excess water causes the ethanol to separate from the gasoline. Methanol is 50% oxygen, so methanol raises fuel octane and volatility. Methanol is highly corrosive. GM recommends only using gasolines with 5% or less methanol. Another oxygenated fuel is gasoline blended with methyl tertiary butyl ether, or MTBE. MTBE raises octane and is less sensitive to water than ethanol. The most common MTBE concentration in gasoline is about 8%, equivalent to about 1 octane number.
Okay, now let's talk about volatility.
Volatility is the fuel's ability to change from a liquid to a vapor. And that's pretty important because only a fuel's vapor will burn and not the liquid. But the evaporated and compressed fuel in a cylinder just doesn't burn when the plug fires, it explodes. Nonetheless, summer blended fuel evaporates slower than winter blends and has a lower volatility. This prevents excessive evaporation and vapor lock. Winter blended fuel evaporates fast and has high volatility. This promotes good cold starting ability. In recent years, fuel volatility has generally decreased. This drop in volatility is significant. In fact, using 87 pump octane fuel may actually improve performance because the higher octane additives increase octane but decrease volatility. Well, Ken, that about does it for theory.
Well, thanks very much, Les. Would this be a good time to talk to Auburn Perkins?
Now, that's a good idea. Auburn does all of our fuel analysis testing in this laboratory.
This is General Motors Fuel Testing Lab, and this is Auburn Perkins. Auburn, nice to see you.
Hi, Ken.
Auburn, would you tell us exactly what it is that you do here?
Sure, Ken. This is a fuel lab where we check all incoming fuels to make sure they meet specifications for our test vehicles. First of all, we do a read vapor pressure test, a distillation curve, and fuel separations.
Okay. Where do you start?
With the read vapor pressure test. Before testing, we chill the fuel samples. They must be between 32 and 34 degrees Fahrenheit.
Okay.
A precise amount of fuel is poured into a test cylinder and sealed. The water bath temperature is held at a constant 100 degrees. When I immerse a container, the water heat makes the fuel vaporize. We measure the pressure created by the test. This fuel is at 10.2, which is typical of today's fuels.
This is the read vapor pressure that's used to rate the volatility of all motor fuels?
That's exactly right.
Okay, and that's the same process used by the gas check kit available to a dealership.
Right.
Good.
And now would be a good time to do a distillation curve.
All right. In this test, fuel is boiled and evaporated. The distillant is processed and it's measured.
Sensors feed information to a computer. The printout shows the temperatures where fuel starts to boil, how it boils, and when the fuel stops boiling. The curve printout shows the exact volatility property of the fuel anywhere on the curve. This graph shows the curve of a good fuel. The second graph shows the curve of a bad fuel. Notice the raised areas. This shows where fuel performs poorly. If an affected temperature range is critical to coal drivability, hard cold starts could easily result. This test separates the three major fuel components. Fuel is injected into the top of a glass tube filled with silica gel. The tube is attached to a pressure source. Air pressure forces the fuel down through the silica gel column. The fuel separates in the silica gel. Special dyes and the use of black lights help distinguish the separations of the aromatics, olefins, and paraffins. Technicians need to know about bad fuel as it can cause many drivability problems.
You're right, Auburn. And Auburn, we'd like to thank you very much for your cooperation and for your insights into today's fuels.
You're welcome, and come by anytime, Ken.
Drivability problems, especially coal drivability problems, are getting tougher to solve, and that's because volatility is getting lower in order to reduce emissions. In fact, depending on the part of the country, the Clean Air Act amendment limits Reid vapor pressure, RVP, to between 7.8 and 9 pounds per square inch for 1992 summer fuel. Now, the only thing certain about future fuels is a lower RVP. Well, that's the first portion of our fuel story. For the other portion, let's see how service technicians diagnosed fuel-related drivability complaints. Cold, hard starts, garage stalls, poor cold drivability, tip-in hesitation. While good fuel contributes to good engine performance, poor quality fuel contributes to poor engine performance. If the fuel is not very volatile, unburned fuel may end up in the exhaust. The oxygen sensor picks up a high oxygen content, indicating a lean air-fuel mixture. The ECM or PCM demands a rich mixture. This compounds the drivability problem. Vehicles, like the one on this dynamometer here in the emissions lab, respond to something outside their control, and that's poor quality fuel. Another fuel-related problem is valve deposits. Now, valve deposits are minimized by deposit control agents, and many gasolines have this additive. Valve deposits are either porous or non-porous. Non-porous deposits are not a problem, but porous deposits soak up fuel, and that leans the air-fuel mixture for a moment. And that's just enough to cause tip-in hesitation, especially for 2.8-liter and Quad 4 engines. For very heavy deposits, remove the valve from the head. Use a wire brush to physically remove valve deposits. Recommend changing to a gasoline with deposit control to prevent reoccurrence. For fuel-related drivability complaints, apply a 4-step diagnostic approach. First of all, verify the complaint. Second, verify correct operation of the fuel delivery system. Third, verify correct operation of the fuel control system. Fourth, test the fuel quality. The first step is to verify the complaint. For example, cold start trouble means the vehicle should stay overnight for a cold start evaluation. Now be certain that an actual problem exists. Second, consult the Know-How 123 manual for specific symptoms and the related fuel system tests. Inspect and test the fuel delivery system to verify that fuel enters each cylinder in equal amounts. A close visual inspection of the delivery system may locate an obvious cause. For example, a kinked or split fuel pressure regulator vacuum hose. Then, check the fuel pressure. On PFI engines, check fuel pressure with Tester Kit J34730C. On TBI engines, check pressure with fuel pressure gauge J29658D. Cold start trouble could be low fuel volume, caused by a clogged fuel filter. If fuel pressure and volume is okay, verify fuel control operation. The fuel control system is checked by performing a diagnostic circuit check. Look for any codes. Fuel-related drivability problems may not set a fault code. If no codes are stored, use a scan tool or T100 to see that the proper PROM is installed. Once PROM ID is correct, perform fuel control tests. Fuel control tests consist of a fuel injector balance test or a fuel injector driver test. For example, on a cold hard start, once the conclusion is reached that the vehicle is operating properly, test the fuel in the tank. Service Bulletin 916E3 reports that switching to a different brand of 87 octane unleaded fuel may solve a cold hard start complaint. The bulletin specifies that it may require several tankfuls of a different brand fuel before the condition improves. Fuel quality testing is a critical part of the fuel system diagnosis. One method of testing the fuel is to drop the fuel tank and look inside, at the bottom of the tank. Water forms a separate layer there. The fuel should be clean and bright, not cloudy. If the Kent Moore Gas Check Fuel Test Kit is available, use it to detect water and measure fuel vapor pressure. The basis of the water test is to coat the tip of a special flexible rod with a paste which changes color if it contacts water. Insert the flexible rod into the fuel filler until it reaches the bottom of the tank. Expose the coated tip and then return it into the plastic cover and bring the tester out of the tank. If the color of the paste is noticeably whiter, water is in the tank. The tank should be dropped and the entire fuel system cleaned. The vapor pressure test is a good indicator of the volatility of the fuel in the tank. One fact about fuel is that volatility decreases over time. In other words, a tank of good fuel may eventually turn out to be a tank of bad fuel, which causes drivability trouble. As a part of the volatility test, a chilled gasoline sample is placed in a sealed, heated container. The heat from the container vaporizes some of the fuel. A pressure gauge measures the pressure exerted by the evaporated fuel vapor. This indicates the fuel sample's volatility. Use the alcohol test kit J34353 to indicate the alcohol percentage in a fuel sample. The test cannot distinguish between the type of alcohol present in the gasoline. The result simply indicates the percent of alcohol in the sample. fuel with excessive alcohol content should be drained and replaced with fresh 87 octane unleaded fuel. After completely testing fuel system operation and, if necessary, replacing the fuel, verify the vehicle's cold starting ability. How can you distinguish between good fuel and bad fuel? It's simple. Use the proper fuel testing equipment if it's available. If the test equipment is not available, eliminate the vehicle as the cause of the drivability complaint and then switch to fresh 87 octane fuel. Your customers will be pleased to find that their Buick is performing the way it should. And it's because they've now got the right fuel in their tank.